Hello, my name is also Doliner. Today I'll be presenting my Raspberry Pi 3 Dashcam project. So very quickly we will list out the contents of this presentation. We will begin with a quick introduction explaining what a Dashcam is, while also presenting the project proposed requirements. We have a quick description as well, which explains the primary and secondary modules, as well as a module diagram. We will end with goals, just highlighting the goals of this project and what it's supposed to achieve at the end, and a quick summary. What is a dashcam? A dashcam is basically a camera that's mounted to a vehicle's dashboard and it records footage of what's happening on the road. This is primarily used for collisions, so when a collision occurs, there's something to keep track of what happened on the collision. Particularly police vehicles use this a lot, and normal customers use this type of device for their own safety, so they can show that they were not blamed in a collision. A dashcam works with a first in, first out design, meaning that as it's storing and recording footage into memory, it's gonna be deleted after a certain threshold of the memory is reached. And this threshold is often determined of how much memory you want to keep for permanent recordings, as we will see in a minute. So, as I said, the footage must be stored permanently at the user's request, and it must operate autonomously. So, meaning that whenever you start the car, it should start on by itself without the user having to turn it on. And the recorded footage must be embedded with date and hour. So let's begin with the project proposed requirements. Self-explanatory, we will have to use the Raspberry Pi in order to create a dashcam, that being using the Raspberry Pi compatible camera in order to record data. I will create Python modules that will allow for recording, storing, deleting footage. Should allow also for input and output, so that will be input coming from a sensor and coming from buttons to allow, as explained here, to save footage from a certain time frame when it is clicked. So it would like save 10 minutes, 5 minutes before we hit the button. And it should also allow for a collision detection system that will be explained later on. Part of the requirements is to create an autonomous system that operates each time that the car starts. So whenever we hit the ignition on the car and the battery gets in, we have power, it should turn on and start recording. And it should efficiently be able to turn off so that when we start again, the clocks and everything are timed perfectly so that time can be kept in the recording itself. The dashcam must be able to resume each time, as explained, and it must be packaged in such a way that it can resist temperature changes, which is here in Florida is especially important because the heat can damage the components. So for this project, the primary modules will be recording and storing, which are the most important parts in and of itself. So for recording, we will have to utilize, as explained earlier, the camera, our Raspberry Pi compatible camera. We should be able to append this information such as date, time, and recording length into the recorded video, and format the recording in such a way that it has decent resolution so you can detect and see things clearly, while being lightweight in storage so that we can store 30 minutes or an hour footage. And for storage, as explained, it should store the recorded footage in packets of a specific length, which is limited by the 32 gigabytes of the Raspberry Pi 3. It should delete, as explained earlier, with the first in, first out system. The oldest footage should be deleted after hitting the threshold. And the deletion threshold must be designed in such a way that it leaves enough storage for permanent recordings. So whenever you hit some, because we're storing some information, so there's some information that we have to keep for later on, that being when we hit the recording button, or because of the collision system that we will see in a second. So it is important for the threshold to be designed so that it leaves some room for those type of footage. And we also need to warn the user if there's not enough space for the permanent storage. That being, if we store too much data, it will warn, if we will like turn on LED, warn the user to, hey, come and extract the data and put it into a separate device so that the device can operate properly. So let's go over the secondary modules. So first and foremost, we need to include an input and output for the user. So we will allow the user to permanently store recordings manually so that they are not automatically deleted over time. As explained earlier, that being hitting a button and recording 10 minutes or so on. We should also allow the user to manually stop and restart the recording. There's also a proposed collision detection system, which will be performed by adding a motion sensor into the board itself, which will measure the amount of G forces in a collision so that it can know when a collision has happened and then record data automatically without user input, which will be especially useful in the case that there is a collision with injury that maybe the driver will not have the capability to manually record, manually permanently record the data, so that it does it automatically without the user input. And this will be especially helpful in those cases because if it keeps running on, it will eventually hit the deletion and it will be deleted automatically. So it's a very nice feature to have. So let's go over a little module diagram that I prepared for this. So here we will have our Raspberry Pi system. Within it, we will have our three main modules. Will be recording, storing, and collision detecting. So within it, we will have our I/O devices, which will be our cameras, uh, buttons, many buttons, and our collision warnings, our motion sensor, and so on. So for example, we will have the motion sensor that will communicate with the collision detector algorithm, and we will tell the storage module to, hey, store the last 10 minutes of data or last 20 minutes of data permanently into the storage of the Raspberry Pi. And also if we will have like a button here that says, okay, stop the recording, we will send that to the recording module so that it can stop recording while still keeping the whole system operating. So that meaning the Raspberry Pi can still be on even though there's no recording happening. And there must also be something to tell the user that the recording is stopped. So that will be sort of the input and output characteristics of this project. Now let's go over the goals for this project. The goals for this project is to create quality videos that upon review can identify information such as license plates, street signs, and locations, especially important for accountability. We should specifically create a subsystem that can actually detect collisions and can record the data permanently into memory. The system should also be able to have a minimum 15 minutes of permanent storage. Yet again, the collisions often happens within minutes or seconds. I think 15 minutes is quite a good threshold to hit for the permanent storage, so that you often when you have a collision, you will directly want to put that information into a separate hard drive so you have it in. So that's a given for this project basically. As explained earlier, dashcams are pretty useful tools and very powerful, especially when you want to clear out a court case you don't know or you cannot prove who did an accident. They're very helpful, and especially for insurances and so on. So it is very important for the system to be reliable and comprehensive to the user. We don't want the user to accidentally stop the recording when something might have happened, or we want the user to know how much time will be saved from a recording permanently. So those things are very important. This project focuses solely on how a Raspberry Pi Dashcam will be able to implement such functions as described earlier, so collision detection, permanent recording, and it is important, as said, to be convenient and practical to use.